Have you ever tried to refactor code with a simple text search and just ended up pulling your hair out? Yeah, we've all been there. Well, today, we're diving into a tool that completely changes the game. It moves beyond just looking at text and actually understands your code structure, letting you search, lint, and rewrite it like you've never been able to before.
So let's start with a classic problem. You need to find every single console.log in your codebase. Simple enough, right? You reach for grep or maybe your editor's find function. But what happens when your code isn't, perfectly formatted every single time?
And yep, here's the problem right here. That first line, found, no problem. But the second one, with just one little extra space between console and .log, nope. Our text search is completely blind to it. And this proves a really critical point. Text search doesn't understand code. It only understands a sequence of characters.
So how do we get smarter about this? Well, we need to start seeing code the way a compiler or an interpreter does, as a structure, not just a flat file of text. And that structure is called an abstract syntax tree, or an AST for short. It's the blueprint of your code's meaning, and it completely ignores all those superficial details like extra spaces or line breaks.
Okay, take this super simple line of code. To us, it's just a string of characters. But to the machine that actually has to run it, it's this meaningful structure with all these nested relationships. Let's peel back the curtain and see what that actually looks like.
And here it is. This is the structure. Our line of code becomes a tree. At the very top, we have a call expression. Okay, what's being called? Well, it's the log property of the console object. And what are the arguments? Just X. Now, this right here is the golden ticket. It doesn't matter how many extra spaces or new lines you throw into your code, this structure never changes.
And this is where our hero tool, ast-grep, comes into the picture. It gives you all the power of searching that complex AST structure, but with the dead simple feel of a command line tool you already know and love. It really is the best of both worlds.
So how do you actually use it? Well, you write patterns that look almost exactly like the code you're searching for. To find a console.log with any single argument, you just use what's called a meta variable. Think of it as a smart, structured wildcard. In this case, $arg will match any single thing passed as an argument. But what if you need to match calls that have, say, 0 arguments, or maybe a whole bunch of them? For that, there's another kind of meta variable. This triple $sign pattern, // args, is incredibly flexible. It'll match any number of arguments, which makes your search patterns seriously robust. Now, finding code is great, but the real magic, the part that feels like a superpower, is when you can automatically change it. This is where ast-grep goes from a cool search tool to an absolute refactoring powerhouse, capable of applying intelligent fixes across your entire project.
Let's look at a perfect real-world headache. In Angular, an @input is optional by default, which means it can be undefined. But look at the type here. It's just string. That's a subtle but super common bug. And trying to fix this by hand in a big codebase? Nightmare.
So, you run ast-grep in its interactive mode, and check this out. It doesn't just give you one dumb fix. It actually understands the context of an Angular @input and offers multiple intelligent solutions. This is so much more than search and replace. This is genuinely code-aware assistance.
And how does it know what to do? Well, you don't have to be a wizard. The logic is just defined in a simple YAML file. The fix key here specifies the replacement pattern. It just takes the type it found and tacks on /undefined. It's readable, it's maintainable, and it's just incredibly powerful.
And just like that, here's the result after we applied 2 different fixes. The first one got the correct union type, and for the second one, we decided to make it required instead. All of this done automatically, consistently, and literally in seconds. Okay, if you thought that was cool, you might want to buckle up because we're about to talk about a true superpower. What happens when you have code from one language embedded inside another, like JavaScript inside of an HTML file? This is where pretty much every traditional tool just completely falls apart. So here's the challenge. We've got a standard HTML file. Inside that file, there's a script tag, and inside that tag is a plain old JavaScript alert call. How on earth would we write a lint rule to find something like that? And here is the magic. You don't write some complex HTML parsing rule. You just write a JavaScript rule, exactly like you normally would, using the pattern alert $MSG. You simply tell ast-grep that you're looking for JavaScript, and it does all the heavy lifting to find it inside the other file.
And boom, there it is. It correctly finds the JavaScript alert call and flags it, pointing you directly to the right line and column inside the .html file. This feature, it's called language injection, is an absolute game changer for working with modern frameworks.
So let's just quickly recap the big ideas here. First, with ast-grep, you search by code structure, which makes your searches totally immune to formatting quirks. Second, you can automate those complex, tedious refactors safely and consistently. And finally, you can lint and fix code even when it's embedded in a totally different language.
So I'll leave you with this question. Think about your own projects right now. Think about that one annoying, repetitive code change you've been putting off because it's just too much of a pain. With a tool like this in your back pocket, what's the very first refactor you could finally automate?